In this video, we will talk about prime numbers and how to get the prime factors of a given number. Okay, so our examples or sample questions that we have today are find the unique prime factorization of 72. And the next one, what are the prime factors of 36? Write your answer in index notation. Okay, now let's start first with prime numbers. Now what are prime numbers? Now when we say prime numbers, these are numbers that have only two factors. You have only two factors, okay? 1 and itself. Okay? Now what are the examples of these numbers? Okay, so let's say what are the prime numbers or what are the first prime numbers? Okay? So examples of this one is we have 2, 3, 5, 7, 11, 13, and so on. Okay? Again, when we say prime numbers, there are only two factors, 1 and itself. Like for example, in this one, 2. The factors of 2 are only 1 and 2. For 5, we have 1 and 5, and so on and so forth. Okay? Now, those that are not listed as prime numbers is called composite numbers. And when we say composite numbers, these are numbers that have more than 2 factors. Okay? Like for example, okay, so for example, it's 4. Okay? What are the factors of 4? Now we know that 4 can be 4 times 1 or 2 times 2. So therefore, the factors of 4 are factors of 4. So we have 1, 2, and 4. Okay, so just remember again, prime numbers, we only have two factors, 1 and itself. Then for composite number, we have more than 2 factors, 1 and other number and the number itself. Okay, now let's go to the given question. Find the unique prime factorization of 72. Now, what do we mean by prime factors? Now, we define prime factors of any given number to be any factor that the number has that is also a prime number. Okay? Now, every positive whole number has a unique prime factorization. It is a list of prime number that is, when multiplied together, gives you the original value or the given number. Okay? Now, again, we have prime factorization. Now, we have prime, so meaning the factors or the numbers that we will be multiplying together must be prime numbers. Okay? Now, the easiest way to do it is using a factor tree. Okay? So, how to do this factor tree? Okay? So, first, let's start with 72. Then, What are we going to do with this one is we're going to put 2 branch here. Then we'll think of a factor that when you multiply together, the answer is 72. Okay? That is why it is very important that you learn first or revise divisibility rules so that it will be easy for you to factor out a certain number. I will put in the description box below the link for the lesson for divisibility rule, okay? But for this one, we can have 2 times 36. Okay? Now, 2 times 36 is equal to 72. Now, 2 is already a prime number, so we're going to encircle that, okay? Now, the next one is for 36. 36 is not yet a prime number, so we will factor out 36. Now, what will be factors for 36? So, we can have, let's say, 4 times 9, right? 4 times 9 is equal to 36. But 4 and 9 is not a prime numbers or prime numbers. So what we're going to do, we need to factor this out. So the factors of 4 is 2 times 2. Okay? Now 2 is a prime number, so we don't need to factor out 2 anymore. Okay? Then for 9, we have 3 times 3. And 3 is a prime number. Okay? So if we write 72, if we write the prime factorization of 72, then 72 now is equal to 2 times 2 times 2 times 3 times 3. So this is the prime factorization of 72. As you can see, the factors or the numbers that we multiplied together are composed of prime numbers. Okay? Now let's have another example. Okay. Now what are the prime numbers of 36? Write your answer in index notation. Okay. Now for the discussion of indices and roots, I will put the link also in the description box below. Okay. Now again, we will do the factor 3. So we have 36. Okay. Now, we will think again of factors of 36. We have 2 times 18. Okay. And we know that 2 is already a prime number. Then we're going to factor out 18. 18 is, yes, we can have 3 times 6. Then 3 is already a prime number. So what are we going to do next? Then we have 6. Now 6 is 2 times 3. And 2 and 3 are both prime numbers. Okay? So the prime factorization of 36 now is equal to, now in this case, we're going to put it in least to greatest. Okay, so that for organization, and it will be useful in our next lesson if we try to arrange it in numerical order. So we have 2 times 2 times 3 times 3. Okay? Or it says in the problem that we need to answer it in index notation. Okay? So here we will use exponents. Again, The discussion for indices or exponents and roots will be put in the description box below. Okay, so like this one, so 36 now is equal to, now we have two numbers here. We have 2 times 3. Okay, now here we will count how many times 2 is multiplied by itself. Now it says here that it's only 2, this one. So we're going to put 2 here, meaning 2 is multiplied to itself 2 times. And for 3, this one, so again twice, so we will put it like this. So the index notation for the prime factors of 36 is 2 raised to 2 times 3 raised to 2, or 2 squared times 3 squared. Okay? Now, why do we need to understand prime factors? What's the use of this one? Okay? Now, understanding prime factors is important to be able to find the lowest common multiple or the highest common factor of 2 or more numbers that we will be discussed in our next lesson. Okay? So, I will put that link in the description box below. Okay? So again, don't forget to like, share, and subscribe to our YouTube channel, Patrick School from Home. For any questions or topic that you want to learn, just leave a message in the comment section or in our Facebook page or email address. See you in our next lesson. Bye!